So, if you've been studying physics for a while, you will know what a radian is. If you haven't, you need to know. So what is it? Well, it's the SI unit of the degree, and we use it in physics all the time. It's not just in circular motion. We use radians to express all sorts of things. Like, we use radians to express phase difference and path difference. Well, actually just phase difference. But yeah, you might not know what that is yet, you might already. But what I'm saying is that it's a very universal and very important concept that you need to get your head around. So watch the tutorial video, and I'm going to talk about what they are, and I'm actually going to derive this equation, because R equals R over R makes not much any sense at all. But soon you will understand what it means. Check it out. Alright, so let's talk about radians, okay? What is a radian? Okay, well, the radian is effectively the SI unit. Oh goodness. It is the SI unit for the angle, okay? It's the SI unit for the angle. And it's defined as the angle that is subtended by a circular arc with a length that is equal to the radius of the circle. So what does that mean? Well, we get 1 radian, okay, when the length of the arc that is subtended is equal to the length of the radius of that circle. Okay, that's 1 radian. So if my radius is 2 meters and my distance subtended is 2 meters, I get 1 radian. Okay, and that is equivalent to approximately 57.3 degrees. Okay, so 1 radian is that many degrees. And the angle in radians that is subtended by any arc is expressed by this equation, okay, where the angle in radians is equal to the arc length here in blue, divided by the radius, okay, and that's important to remember going forward, okay. But let's discuss this in a bit more detail. Let's discuss why 1 radian is equal to 57.3 degrees. So if we know that because C is equal to pi d, okay, we can rearrange that, and we can say that pi is equal to circumference divided by diameter, which we can further rearrange to say that pi is equal to circumference divided by 2r, because we know that d is equal to 2r, 2 times the radius. And we can rearrange that whole expression to say that c is equal to 2 pi r, where we just multiply both sides by 2 pi r, okay, and we get c is equal to 2 pi r. Okay, so that's the first part of our expression. And if we know from our previous slide that the degrees in radians is equal to this arc length divided by the radius, okay, and if those two are equal, then we get 1 radian. We talked about that already. If we extrapolate from that and we talk about the number of arc lengths in an entire circle, which has to be equal to the circumference, if that arc length is the circumference, okay, then we say that in an entire circle, the number of radians is going to be 2 pi r over r, where r is the radius, okay, and 2 pi r is the arc length, but in this case it's the entire circumference. And if we divide through by r, we see that the number of arc lengths in an entire circle is equal to 2 pi, okay? And if we multiply that out and we get a number, we see that there are a total of 6.28 radians in 1 circle, okay? And if we divide 360 degrees by that, because there's 360 degrees in 1 circle, we see that we have got 57.3 degrees in 1 radian. Okay, so that's just a bit of proof to help you understand what a radian is and where it's actually come from. Pretty useful, I think. And from that information, we can sort of learn how to convert between radians and degrees. Okay, so because 360 degrees is equal to 2 pi radians, when we want to convert from degrees to radians, all we have to do is multiply by pi divided by 180, and to go from radians to degrees, we have to multiply by 180 divided by pi. Okay, so it's definitely worth. I mean, you might be able to see this little thing in the corner. It's definitely worth remembering that that multiplier when you're moving between the two things, and you can effectively remember it just by remembering this here. Okay, but 360 degrees is equal to 2 pi radians. Okay, here are some questions as well for you to try if you like. But yeah, this is the tutorial
for this video. Just if you want, take a screenshot of this or whatever, just to help you practice. And then these are the answers as well, just in case you need them. But yeah, hopefully this has helped you.
Okay, so hopefully you now understand what radians are a bit better. It's not too complicated, just takes a bit of practice. I put some practice questions in the video. Those are my actual slides, right, by the way. I used those when I taught this lesson. Josh, if you're watching, then you obviously, hi. And Monty and Sam, and I'm not doing the whole class. Hi! But yes, those are my actual slides, so they're good. They've been checked, everything is good. But yeah, just practice it because you really do need it later on. Like and subscribe, share the physics love, because we love physics and we want you to get good at it and love it, and it's going to be fun, okay? Yeah, see you next time for the next circle video. Circles.